to this session. Today we are going to discuss about the types of loads acting on the beam. In the earlier class we already discussed about what is a beam and how can we discuss and well as how can we classify a beam based on the types of supports and the number of supports and the location of supports. Today we are going to discuss the types of loads acting on the beam or lateral load. These are called lateral load. First one is point load. It is otherwise called as concentrated load. The second one is called as uniformly distributed load. Generally it is being given as UDL, uniformly distributed load, and the third one, uniformly varying load. And it can be given in terms of UVL. Okay, so these are the three loads acting on the beam. One is point load, and the second one is called uniformly distributed load, and the uniformly varying load is the third one. Now let's discuss how can we find the total load acting in each and every beam. Now let's discuss now. Now let's take a beam having two supports. Generally, a point load is represented like this. This is called a point load. Let's say 10 kilonewton. Okay, this is called a point load. And the second one is called this is called uniformly distributed load, and this uniformly distributed load is measured or is given in terms of load per the total distance covered. Okay, this is called the intensity of load. 10 kilonewton per meter is the uniformly distributed load. It is not in terms of kilonewton, it is given in terms of kilonewton per meter. That is very important, but point load is given directly the load. And what about uniformly varying load? Uniformly varying load, it is being given like this. I can find. So here the variation from this point to this point. Okay, the height is measured, given as the load. So let's take this is about 100 Newton per meter. And for this given length, okay, let's take x is the given length. At this point, the intensity of load is 100 Newton per meter and goes on decreasing. And at the point, this point, the extreme end, it is 0. That is uniformly varying. Now let's discuss how to find the total load. Generally, we can discuss about the uniformly distributed load. The uniformly distributed load is taken like this. Okay. Generally, this uniformly distributed load, the shape, what is the geometry of the uniformly distributed load? The geometry is nothing but rectangular in shape, and this is the downward load. Okay. It represents the downward load, and this height gives you the intensity of load, how much load it is. Okay, if it is given 100 Newton per meter, okay, so this will be 100 Newton per meter, this height, and it is uniform through the section. Let's take the span of the beam is 10 meter. Okay, get the same thing right. Okay, 10 meter. Now how can we get the total load due to this uniformly distributed load? Let's take 100 Newton as it is known, and where the load is active. For 10 meter, it acts from this point to this point, or 0 to 10 meter, and where the load is active. So those things we are going to discuss here. For uniformly distributed load, we have to get the total load. How to find? For this, same 10 meter I am taking without support, just I am indicating without support. Okay. The area of the geometry will give you the total load. How to find the area? The geometry. And I already told, for uniformly distributed load, the geometries are rectangular one. So the breadth into this height will give you the area. So 100 into 10. Okay, 100 into 10 will give you the area. So 100 into 10, as well as the unit will be this Newton per meter. This is meter. So we will get the Newton as the unit. And okay, now I got this is the 1000 Newton. 1000 Newton. And where this 1000 Newton is acting? Actually, we are converting this uniformly distributed load into a point load where it is acting. That is the machine. So we already know that a point at which the whole weight of the load is acting is called centroid. Okay. Then what is the center of the rectangle section? It must be at the center point. So 10 meter. So centroid will be at the center. That means 5 meter and 5 meter. So totally 1000 Newton. So this is the methodology to convert the intensity of load of a uniformly distributed to a point load. Okay. So this is the methodology. Now we can go for the uniformly varying load. So UVL, okay, uniformly varying load. Then it is a right angle triangle, okay. So it is also downward load, and the intensity of load will take the same 100 Newton per meter, and here it is 0, okay, varying uniformly. Let's take the span of the beam is 9 meter. Okay. Now we have to find the total load, which is concentrated as a point load. Okay. What is the magnitude as well as where it is acting, the location of the load. Okay. And I already told the total load is found out by means of finding the area of the geometry. Now the geometry is a right angle triangle. So half into BH is the area for right angle triangle. So finding this area, you can get the total load. So half into B, base is 9 meter, and the height is 100 Newton per meter. Okay, 100. So here Newton per meter is meter, so we will get the Newton only. So finally 2 into 100. Okay, so 450 Newton is the total load, which is considered as a point load. Okay, now I just take this 9 meter and the point load to be considered as a 450 Newton, and where it is acting. That is the question. In uniformly distributed load, it is acting at exactly the center point. But in UVL, it is considered as a right angle triangle. So how to find the centroid? We are considering only the x-axis, that is x bar. For right angle triangle, x bar equal to, okay, this is base, okay, and this x bar to be considered. How to find this x bar equal to 1/3 of the base from the this maximum height, okay. So 1/3 of the base will be the centroid. Okay. For this problem, 1/3 of the base. So this base will come as 1/3 into 9. So we get to 3 meter. Okay. So centroid is acting from here, it is 3 meter, and the remaining is 6 meter. Okay. And the total load, since it is a downward load, the point load will be a downward load. The point load is 450 Newton. Okay. So for this case, the total load is 450 Newton, which is acting 3 meter from the left support as well as 6 meter from the right support. So this is the methodology to convert the intensity of the load for a variable, uniformly varying load, to be converted into a single point load and to be located at this point. This is the concept. So thank you for watching this session. Thank you.